So we are actually skipping to chapter 8. So this chapter 7 and 8 combined actually is what we're doing. And so our learning goal for today is I understand how to use random samples to make conclusions about populations. So our warm-up is that you have 5 hats and 3 pairs of sunglasses. How many possible combinations do you have? And I want you to use a tree diagram to also show your work. So yes, there's kind of a little cheat or a little formula you can use. I want you to do both. So you're going to do that now, and then you're going to check your answer with mine. So H1 is just hat 1, hat 2, hat 3, and hat 4. And then for each hat that I have, I can wear one of my 3 sunglasses. So I have sunglasses 1, sunglasses 2, or sunglasses 3. Those are my 3 options. So I have 3 branches going off of each of my hats. And so when I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I have 12 options that I can wear. You also can do 4 times 3, which is 12. All right, so we are going to start our new topic. So before we start, we need to know what unbiased and biased means. So unbiased is a representative of a population. It is selected at random and is large enough to provide accurate data. A bias sample is not a representation of the population. One or more parts of the population is favored over the other. So for example, if I am wondering what the best type of dog food is, I am not going to ask people who have cats, right? And only cats. You cannot, and do not think what ifs. Remember, we already talked about how you can't think what if, well, what if they have a, nope. If I am looking at the best type of dog food, I'm going to ask people that have a dog. Or like the most popular dog food, I'm going to ask people that have a dog. So I need something that's unbiased, which means it represents my population. Everybody would have a dog, and I would need to ask enough people that I can get an accurate set of data. If I choose to ask only people who don't have dogs or who have never had a dog, then that's bias because they do not represent the population that I'm looking at. And my population is the people, like the best type of dog food. So I'm looking at pet owners or dog owners, right? So unbiased is when it represents my sample and it's random. That's the key word, it's random. Bias is when I favorite something. So I purposely ask a certain group of people that I know don't have a dog, and that way it will sway my data. So, for example, you want to estimate the number of students in a high school who ride the bus. Which sample is unbiased? So, if I ask 4 students in the hallway, that's not enough people. If you've ever been to Park Hill South, which is where most of you guys will be going to high school, the hallways are actually separated per grade level. And so if I only ask 4 people in one hallway, then most likely I'm only asking 4 people of the same grade level. So that's not a good representation of the whole high school. So my high school is my population. If I ask all the students on the soccer team, so sorry, this one's biased. If I ask all the students on the soccer team, I'm only asking players on the soccer team. For example, most sports in high school have practice before or after school, so most of those students don't ride the bus to and from school. So most people on a sports team actually don't ride the bus because they have practice. So this would be biased because I'm only asking one group of people. Everybody in the high school doesn't play soccer. That's not a good representation of my whole school. So this does not represent my whole school, and it's not random. So this is also bias. If I ask the 50 12th grade students at random, this is also going to be biased. So yes, it's at random, which is awesome. We like that part. but I'm only asking 12th grade. And here's why it's biased. So you turn 16 as a sophomore. So that's grade 10, right? So if I'm asking all 12th graders, most 12th grade students can drive, which means that most of those students probably drive to school or have a friend that can drive them to school. And so that's not representing my whole high school. In high school, we have freshmen, sophomore, juniors, and seniors. We need to represent all of them. And so 12th grade does not represent all of my high school. So that leaves option D, which would be 100 students at random during lunch. This is perfect because during lunch, you have freshmen, sophomore, juniors, and seniors. And if I'm asking random people, I have a chance at asking freshmen, sophomore, juniors, and seniors. I'm not only targeting one age group. So I'm not purposely trying to sway my data to look a certain way. So since it's 100 students at random and it's during lunch when all the students are represented, this is unbiased. So I want you to try 1 and 2 on your own, and then you're going to check your answers with mine. Number 1, it says you want to estimate the number of 12th grade students in high school who ride the bus. So now I'm only looking at 12th grade. So now I would pick C because I only want to ask 12th graders. If I only care about how many 12th graders are riding the bus, then I'm not going to ask people from other grades. So I'm going to go back up here and I'm going to pick option C. Number 2, you want to estimate the number of 8th grade students in your school who find it relaxing to listen to music. You consider 2 samples. You have 15 randomly selected members of the band, or you have every 5th student whose name appears in alphabetical order of 8th grade students. So the first one is biased because most people in band like music. So I would already assume that most of them would find it relaxing. Option B, or the second one, every 5th student whose name appears in alphabetical order. I can't predict whose name's in what order of all of 8th grade, and so that would be random because I'm randomly picking the 5th person, every 5th person on that list. And so that one represents all of 8th grade, so that's a good representation of my population. All right, so you want to know how the residents of your town feel about adding a new landfill. Determine whether it is valid. So if it's valid, it's random and it's not biased. So you survey 100 residents who live closest to the landfill. The diagram shows the results. You conclude that 10% of the residents in your town support the new landfill. Is this valid? This is not valid. This is bias. And the reason it's biased is because they only asked people who live closest. And when they ask people who live close to the landfill, yeah, they're going to be bothered by it. They're not going to want a landfill right next to them. Kind of like when in Parkville, they wanted, well, right next to Thousand Oaks, they wanted to build those like motels, hotels, shopping centers, and stuff like that. People in Thousand Oaks in that neighborhood were really upset. They're like, no, I don't want that in my backyard. While people in Parkville were like, yeah, let's do it. It'll help our economy. It'll help us out, our town. So people of Parkville who didn't live in Thousand Oaks were for it, but people in Parkville who had to look at it and have to look at it, they were against it. And so we want things that are the whole city, not just those that live next to it. So you survey 100 residents at random. The table shows the results. I forgot to add the table, my bad. But 60% of the residents in your town do not support the landfill. This is valid because you did at random 100 people in the town, not just the people living around the landfill. So now I want you to do this one on your own and then check your answer with mine. So this one is not valid because you asked only 5 people, and 4 out of 5 people does not represent the whole town, you know? So this is not valid because it's not a large enough group. If you asked like 100 people or even 50 people, then yes, it would be a large enough group. But 5 people, just randomly asking 5, that doesn't make your conclusion valid. All right, so you ask 75 randomly chosen students at a school how many movies they watch each week. There are 1,200 students in the school. Estimate the number of students in the school who watch one movie a week. So we're looking at this section right here. So we have 21 students out of 75 from our randomly chosen students said that they watch one movie per week. So if we were to guess how many in the whole school, which we're saying there's 1,200 people in the whole school, how many people or what portion of people would say that they only watch one per week? Now, again, this isn't going to be exact. You're just making an estimate. So remember doing this, we're going to cross multiply and then divide by our third. So we are going to do 21 times 1,200 is going to equal 25,200, and then we divide by our third number, which is 75. So we would say 336 people in the school would watch only one movie per week. That's not exact, but that's our estimate. So we're using our prediction. We're using our data to then make a prediction about the future. So remember how last time in our chapter 7, we were talking about how we can't we can't know the future, but we can make predictions of the future. And so that's what's happening here. We're using math to then predict what would happen in a bigger group.